Hello, in this tutorial, I'll be showing how we can run both machine learning training and inference at the edge while using a microcontroller such as the XIAO ESP32S3 board. This board comes with an onboard camera sensor and also an SD card slot. The first thing is to clone this GitHub repository, which has an Arduino sketch and also web files for serving a user interface. In the Arduino code, we need to paste the Wi-Fi credentials that you want the XIAO board to connect to, and we need to also ensure that the ESP board has been installed, and we select the XIAO underscore ESP32S3 board. Ensure that PSRAM has been set to OPPSRAM and select the correct COM port of your XIAO board. Once you have done that, you can open the serial monitor and you should see logs coming from the XIAO board. Here we will see the IP address that has been assigned to the XIAO board, and we need to copy this IP address and paste it to the ESP32S3 IP address variable, which is in the index.html file, which is in the web underscore AI folder. Once you've pasted that IP address, you need to copy the web AI folder and paste it to an SD card and insert the SD card to the SD card interface of the XIAO ESP32S3 board. Once you have done that, you can open a web browser and you should see a web interface which is being streamed from the XIAO board, and the camera feed is coming from the onboard camera sensor of the XIAO board. So right now I have the XIAO ESP board which is faced towards me, and you can see live camera feed coming from the board. I can select a class to capture an image for, and these classes have been defined in the class labels array, which is still in the index.html file. If you want to add another class such as a car, you can simply add a new item to this array, and you also need to ensure that the image counts per class array matches the class labels array. We can go back to the browser. I will select the current class as person. I will capture images of the person, which in this case is me, and I'll put various variation of what the person images looks like. Let me go to 25. I will go to the next class, which is no person. Let me hide myself. I will capture an equal amount of images for this class, and I will train a model. This training process will happen in my browser, and in this case it will train a simple convolutional neural network which has very few layers, and the image is being processed at 96 by 96 pixels. Once the training process has been completed, the model weights and structure will be sent back from the browser to the ESP board, and the XIAO board will save the model structure file, which in this case is a model.json file, and the weights will also be saved in the root directory of the SD card. This process will take some time, but right now both the weights and also the model structure files have been completed. If you go back to the browser, inference, it will start immediately, and right now you can see that the model is correctly predicting that it's seeing a person, and if I had myself, you'll see that the model is correctly predicting that there is no person. When a new client connects, I will open I can refresh the screen. When a new client connects, in this case, since there is a model that is existing on the SD card, the XIAO board will serve the model to the client. So the model.json file and also model.web files will be streamed automatically from the XIAO board to the client, which in this case is my browser. And this process, it might take some time because the XIAO board needs to read the file from the SD card and also stream it. But once it has been completed, inference will continue automatically. So like before, the model is correctly predicting that it's seeing a person. If I had myself, the model is predicting that it's not seeing a person. And we can capture more images and also retrain the model.